Welcome back. In this session, we will discuss about selection statements. In C programming, the statements are by default executed in a sequential manner. But if you want to control the flow of execution of the program, then we have to use control statements. Now suppose based on a condition, if a particular part or block of a program to be executed, then we are going to use selection statements. The selection statements are also known as branching statements. So they allow you to branch or move to a particular branch of the code, my dear friends. And we classify selection statements into two types: conditional selection statements and unconditional selection statements. So under conditional selection statements, we are having the if statements like if else, nested if, else if ladder, etc. So I just call them as if statements. And we also have a special one which is called switch case, which is mainly used for the menu driven programs. In this session, we mainly talk about the if statements. And unconditional statements, the main unconditional statement is go to statement. Actually, the go to statement create unstructured programming, which is not a desirable method, but C also allows you to create unstructured programming using go to. See, unstructured programming means you start here, you move here, then from here you can go back to some previous stage. So C allows you to move front and back using this go to statements. So that is what we call it as unstructured programming. And this break and continue are mainly used with loops, and we use the return statement to return the value from a function. So these are the selection statements, but in this session we are going to talk about if statements. If statement. If statement is a simple selection or decision statement. Okay, this flow chart explains how this if statement works. First, the condition is verified. If the condition is true, then the if block, that is the block of statements under if, are executed in a sequential manner. That is, all the statements which are under this if block are executed. Then the next statement after the block is executed. Suppose if the condition is false, then this if block is completely ignored, we directly move to the next statement after the if block. Now let us see the syntax of if statement. Here we have this if, lowercase letters, then this condition can be any condition. It can be logical condition, relational condition, okay, we can have the relation between two variables, okay, whatever condition which returns either true or false is kept here. Now this is called the block of if or if block. Now the statements to be executed when the condition is true. So these are the statements which are to be executed when the condition is true. It is just a syntax, try to understand the syntax here, okay. So all these statements are executed one after the other sequentially if the condition is true. After that, the next statement is executed. Suppose if the condition is false, this entire if block is ignored and directly we move to the next statement. Let us consider this simple program. We want to verify a given number is even or not. Actually, we are only printing if the number is even, otherwise we are not doing anything in this program. So we define a number num, asking user to enter a positive integer. So whatever number is entered using the scanf, we are assigning to num. Now I need to write the condition for even. When the number is even, sir? When you divide by 2, if the remainder is 0, then it is even number. And for remainder, we have a beautiful operator percentile. So num percentile 2. If num percentile 2, that is remainder, is equal to 0, then it is even number. So that is the condition, my dear friends. What is the condition? Num percentile 2 is equal to 0. So if it is 0, that is if the condition is true, then this printf statement is executed. That is %d, that is num is even number. Whatever number you enter, that number is even number. And if it is not even, we not return any code for that. So program simply terminates. So let us run this code and verify our output. So let us run, let us enter 48 and it clearly given 48 is even number. Let me give odd input 35, it will terminate simply. Now one more important point, this is if block. Actually this block is needed when we are having 2 or more statements. When we are having a single statement, we can ignore this block, my dear friends. That is, this block can be omitted. Still the program runs. One second. Still the program runs. Let us see this. So if you enter 48, it is even number, and if you enter any other number, it simply terminates. My dear friends, this indentation which we kept is only a good programming practice. Even if you don't indent also, there is nothing wrong. But it is a good programming practice to keep that indentation for these blocks, or within that if or the loops or the selection statement, we always try to keep that indentation so that we understand this is within that particular block. Remember sir, if there is a single statement, then omit the block. If you are having multiple statements, always we have to keep the block, if block. And one more very common semantic error which people do is, after this condition they keep semicolon. This is a semantic, logical error, and there is nothing wrong in it. Let us do this and run the code and see what happens. Okay. Now I enter 48. Wow, it is given perfect result. Now let us run this code with 35. 35 is also even number. So it is not properly giving the output because we done a logical error. See my dear friend, this semicolon should not be given after the condition of if. Actually this semicolon is considered as a single statement. So within the if block we have a empty statement. So what happens if the condition is true, there is nothing to do and this is printed. That is, the number is even is printed. If the condition is false, this empty statement is not executed, but this printf statement is executed. So please be careful. Writing semicolon after the condition of if is the most common logical semantic error. It is not a syntax error. Okay, and program will not warn also, because there is nothing wrong. Syntactically there is nothing wrong in it. It is the logical error. Please be careful. Don't do this mistake, my dear friends. Don't do this. Okay, please be careful. Next problem. What is the output of this program? See, if you want, you can pause and try to write your output and verify. Okay, I am continuing. Now look here, A and B are two variables which are defined, and for A we assigned 200 and for B we assigned 4. Nice. Now the condition A less than 100. Now look here, we are assuming that these two statements are under if, but that is wrong because we not kept the block. If you are having 2 or more statements, you have to keep the block. You not kept the block, then what happens? Only this is considered under if block. This is not under if block. Only this A is equal to A minus 5 is under if block. This is not under if block. See, these are all semantic errors, my dear friends. Please be careful. So here 200 is less than 100? No. So this part is not executed. But this part, because it is not in the if block, because the condition is false, next statement, this statement is executed. So B is equal to B plus 5. So the new value of B is 4 plus 5, that is 9. So when you print, the value of A remains same 200, value of A remains same 200, but the value of B will be 9. So, let us save and run the code. You can see A 200 and B 9. Suppose if I change this like A greater than 100, then what happens? See, because the condition is true, this is executed and this is also executed, okay, which may give you wrong impression that both are under if block. That is wrong. Please be careful. Am I clear? So, if you run this, what happens? Let us run this code and verify. This time what you should get, because both are executed, so it becomes 195 and B becomes 9. Let us save and run, and you can see 195 9. Because this is not under if block, whether the condition is true or false, it is always executed. But this fellow, because that is the only statement under the if block, if the condition is true, that is executed, otherwise it is not executed. See, when it is greater than, it is executed. When it is greater than, then it is executed. Note that. Next program. What is the output of this program? This is a very interesting question. So, they give you different option like only hard work is key to success is printed, or only C programming language is printed, or both the statements are printed. Like that, different options can be given. What is the output for this program? So, here the value of x is equal to 7. The first condition is x is greater than 8, that is false. X is greater than 8 is false. So, we assume that this statement is not executed. And here x is less than or equal to 8 is true. So, we expect that only C programming language is printed. So, the expected output for this is C is a programming language. Whatever the statement is executed, programming language. This is what you expect, okay, small l. It is printed as it is. But you see the semicolon, the dangerous semicolon. So, how it is considered? Under this if block, we have empty statement, then we have this printf statement. That is, hard work is key to success is printed, and C is programming language is also printed, okay, because there is no \n, both are printed next to each other, my dear friends. That is, hard work is key to success, then there is a space followed by C programming language. C is a programming language, both are printed. So, please be careful with this semicolon, my dear friends. If else statement. So, for if else statement, we have two blocks. One is if block, the other one is else block. This simple flow chart explains this if else statement. So, first we verify the condition. If the condition is true, the if block, whatever if block we write, that portion is executed. After that, whatever statement is there after that entire if else blocks, that next statement will be executed. And suppose if the condition is false, if block is ignored, then else block is executed, then the next statement after complete if else block is executed, okay. Now, let us see the syntax of if else statement, and it is a bidirectional conditional control statement, bidirectional. So, we are having two directions, condition is true one direction, condition is false other direction. So, if the condition is true, these statements which are under if block are executed, and if the condition is false, this if block is completely ignored and the else block is executed. That is, the statements under else block are executed. Whatever it is, whether it is condition true or false, after if block or after else block, next statement will be executed. That is, if condition is true, if block followed by next statement, if the condition is false, else block followed by next statement. Let us consider the following simple example. Here, we want to find largest of two given numbers. So, we define two integers a and b and asking user to enter two numbers, okay. So, whatever numbers are entered, the scanf function assigns the values to a and b respectively. Now, we need to give a condition. See here, I am writing which one is larger. See here I want to say A is larger means the condition should be A greater than B, then I print A is larger. Else, see if A is not larger, obviously B is larger. Now we can say users to enter two different numbers. See otherwise what happens if they enter equal numbers? Even if they are equal, it says B is larger number. Am I clear? See otherwise you have to use one more else if ladder. There we have to say that A is larger, B is larger, or A and B are equal. That can be used in else if ladder. We will understand little later. Hope you understand. So we are asking user to enter two different numbers. Am I clear? Nested if. Dear friends, the if constructs can also be nested. That is, within the if else blocks, we can also have other if else blocks. So if you consider a if block, inside that we can have sequential statements, we can also have only if block, or we can also have if else block. Similarly, in the else block also, we can have sequential statements, we can have if block, we can also have if else block. And this is what we call it as nested if. And this nesting can be done to any level, my dear friends. Let us consider one simple example where we can use this nested if construct. Suppose I want to find largest of three numbers, and suppose the three numbers are A, B, C. First we start with the condition A is greater than B. So this condition may be true or it may be false. So this is your if else block. So this is if block and this is else block. Now suppose if it is true, we enter if block, that is A is larger. Out of AB, A is larger. Now we have to compare A with C. So within this if block, we are having another if else block. That is, we consider or we compare A with C. A is greater than C. It may be true, that is if block, or it may be false, that is else block. Suppose if it is true means A is larger than B and larger than C, therefore A is larger. Suppose if it is false, A is larger than B, but C is larger than A means ultimately C becomes larger. So within the if block, we are having if else block. Now suppose if it is false, we enter else block. Now here B is larger. So compare B with C. Again we have if else block. It can be true, it can be false. Suppose if it is true, B is larger. If it is false, C is larger. Let us run this code and verify the output. Consider the program. We defined three variables ABC, asking user to enter the values of ABC. Whatever values entered, the scanf function assign those values to A, B and C respectively. Now the important nested if constructs. First we verify whether A is greater than B or not. If A is greater than B, then within the if block, what we need to do? We have to check whether A is greater than C or not. If it is true, then what is the maximum fellow? A is maximum. Otherwise, C is the maximum. Now suppose if the condition is not true, we move to the else block. That is B is maximum. In the else block, now B is compared with C. If B is greater than C, we print B is maximum, else C is maximum. So let us run this code and verify the output. So let us enter the values 34, 56, 78. Obviously 78 is maximum. If you want, you can enter a different order, sir. 56, 34, 89. Okay, any order you can enter and you will get the correct output for that. Else if ladder. If we have a chain of if else blocks, then we call it as else if ladder. Dear friends, even though we have chain of if else block, only one block is executed. So here first condition 1 is verified. If it is true, then block 1 is executed. Remaining part is ignored. Suppose if it is false, then condition 2 is verified. If it is true, block 2 is executed. Remaining part is ignored. Suppose if it is false, then condition 3 is verified. If it is true, block 3 is executed. Suppose if it is false, then else. Okay, here we not given any condition, it is like a default condition. Okay, then fourth block is executed. So this is how this else if ladder works, my dear friends. Let us consider one simple example for understanding else if ladder. Suppose we want to categorize marks of a student. So the student who get less than 40 marks are failed. Now suppose 40 marks to 60 marks if the student gets, then let us call he is in the second division. Now from 60 to 75, let us call it as first division. Now suppose if we get anything greater than or equal to 75, let us call it as distinction. So this particular program can be written using else if ladder. So what we can do, first we check this condition, that is if marks are less than 40. If it is true, we print failed. I am not writing complete program, sir. After this I will show you the program. Suppose if it is not correct, then we move to the else part. In the else part again we are verifying a condition. What is the condition? Whether the marks are between 40 and 60. See, obviously less than 40 is already considered. You do not even have to write 40 less than or equal to m less than 60, sir. We just need to check m is less than 60, because it is not less than 40 means it is obviously greater than or equal to 40. So greater than or equal to 40 is already within this condition. Now we just need to apply the upper end or upper condition, less than 60. That is enough. Else if it is less than 60, we print first division. Suppose even if it is wrong, else if, now definitely you know marks are greater than or equal to 60, we have to stop at 75. We just need to check whether it is less than 75. Then we print, okay, here it is second division, then here we print first division. Else, now definitely you know greater than or equal to 75, no need of writing the condition. So here we write distinction. So this is how we can write logic for such programs, my dear friends. Let me show you the program and let us run the program and verify the output. Now consider the program. So we defined integer m, asking user to enter the marks of the students. So whatever the value is entered, scanf will assign that particular value to m. Now the condition, if m is less than 40, we are printing failed. Else if m is less than 60, so obviously it is greater than or equal to 40, we know, so we are restricting it at upper end. M less than 60, we print second class. Else if m is less than 75, we print first class, else we print distinction. And actually here I try to write it with indentation, but there is no need of doing any indentation, sir, because else if will take care of the logic carefully. So we can directly write like this, my dear friends. Generally for else if we do not try to use that kind of indentations. For understanding initially I written, but you can directly write like this, my dear friends. It works. That is, if the condition is true, this part is executed, otherwise second condition is verified. If it is true, second part is executed. If it is false, we go to the third part. If it is true, this printf statement is executed. If it is false, then finally we go to the fourth printf, that is distinction will be printed. So let us run this code and verify the output. So let us enter the marks. Hope you get very good marks, and let us see the output. Distinction. You can try other numbers also, sir. Let us try 55 and check second class. Now let us conclude this session with one very interesting problem called dangling else problem. Dear friends, for every else construct, there should be a matching if construct, otherwise it is a error. Okay. Now compiler resolves this by associating every else with the nearest if construct which does not have a matching else. So it will associate the else with the nearest if which does not have the else construct. Now when you get the dangling else problem, and what is this dangling else problem? See, the dangling else problem occurs when an else statement is not associated with a specific if statement. That is, you are expecting this else to be associated with a particular or a specific if statement, but this fellow is matching with something else or some other if construct. This is what we call it as dangling else problem. Let us understand this with examples. Let us consider the following program. Here we are having two integer variables x and y which are initialized with 0 and 5 respectively. Now if you actually observe, we are having this if else block. Due to indentation, we assume that this is the if block and this is the else block. That is our assumption. Okay. So what happens? First, if y not equal to 0, the condition is verified. Y is equal to 5 which is not equal to 0, that is true. Therefore, the if block is executed and whatever output you get there, that is printed and we reach the return statement. That is our expectation. Okay. So y is not equal to 0, that is true, we enter, and x not equal to 0, but x is 0, that is false. So this part, this printf is not executed. So directly we expect return 0 here. Directly we expect return 0. That is, the program terminates without doing anything. That is our expectation. But let us see what is the output and let us understand why we get different output than what we are expecting. Let us save this code and run. We are expecting no output, but you see this particular else part is executed. See, the problem here is dangling else problem. See, now compiler associate this else not with the first if. It will associate this else with the nearest if for which else block is not there. That is, this else is associated with this if. So actually this code is equivalent to this code. So this is how the compiler implement this. Okay, so we get this particular output. That is, we start here, if y is not equal to 0, that is true, we enter, and x value not equal to 0, false. So if block is not executed, then we enter the else block. For this if, this is the else. So if the condition is false, we reach else block. In the else block, error y is equal to 0 is printed. So that's why we get this particular output. So this is what we call it as dangling else problem, my dear friends. Suppose if you don't want this else to be connected to this if, then what we should do is, we should keep a block here. We should keep a block here. That is, this particular if we should close within the block. Then what happens for this if else is not there, the compiler will not associate it with it because this is a block. After the block, what happens? This else will not be considered as corresponding else for this if. This else is considered as corresponding else for the first if only. So if you want to associate else with the first if, you have to use proper block. That is, you have to use this curly braces. Otherwise what happens? This else will be associated with this if. So if you run this code after changing or after modification, let us see the output. Now here it is terminated without doing any or without giving any output. That is, this time else is working as expected. So, for that you have to keep this block which is compulsory. Otherwise, what happens? This else will be associated with this if. Note this point.